Okay, so here we go, part 2. Now we're on page 2, page 78, number 41, about a construction worker accidentally drops a brick from a high scaffold. What is the velocity of the brick after 4 seconds? Now, little hint, you guys, is on the test there's going to be a question like this, and they're going to have a few extra words in there where, it's going to be like, oh, do I need to know this? And one of the things they're going to say is neglecting air resistance. You're going to see that quite a bit on the test, and that just means in the real world there would be air resistance, and so we would not calculate this exact number. So this number is pretending like air resistance doesn't exist. So that's just us being really good physicists. Okay, formula. Here you go. Formula here is going to be velocity final equals velocity initial plus acceleration times change in time. All right, so let's get started here. We need to list out 4 things. So first we've got our velocity initial. Well, hey, that's going to be 0 because the brick was just hanging out on the top of the building until a clumsy person accidentally dropped it. Acceleration, we know, is going to be 9.8 meters per second squared. That is gravity on Earth. And finally, we've got time. We're going to say 4 seconds. You know that 4 seconds for time is going to be time final minus time initial. Okay, so let's plug this in then. We know all of the things we need to know. Now again, you can see this guy is going to 0 out again. If you're the kind of person that can skip that step, more power to you. So now what we're going to do is we're going to take our acceleration here, 9.8 meters per second, times time. Acceleration times time is going to give you the free fall velocity. So 9.8 meters per second squared times 4 seconds. Now, let me show you guys how the units are going to cancel, okay? Okay, so I know a lot of you were wondering how these cancel, so let's do that. 9.8 meters per second squared times 4 seconds. Now I put seconds over 1 like that. Now let's watch how the units cancel. This seconds will cancel here. Now there is no longer 2 seconds in the suitcase, there's just 1. You multiply straight across, and that's how you're going to get your answer, which is 39.2 meters per second. That is your question. So that's about how it's going to look on the test. Then it says, how far does the brick fall during that time? So there's not really one like that, so I'm not gonna worry a ton about you guys. Let me just look at the test just to make sure, but I'm pretty sure. I'm just looking right now. Oh, yeah. Okay, never mind. Let's do this. Let's do part B because that is like one on the test. So part B is, how far does the brick fall at this time? Here is your equation. Now remember, if you can see on your formula sheet, you're probably looking at something that says position final. So here we go. Let me write it down for you. TF plus 1/2 ATF squared. I believe we did this one on the first page, didn't we? Let's list out all of our variables that we know that we need to know. So we've got here our xi, that's position initial, velocity initial, 0, time final, 4. No surprises there. We already knew all those things, didn't we? So we can also see that some things are going to 0 out. Check it out. All these things, this is going to 0 out here. And you're left again with just this one. No big deal, right? 1/2 times acceleration. Now acceleration, we remember gravity. Gravity, meters per second squared. And we've got our time final. So our time final was 4. And don't forget to square it, 4 seconds. Now we'll multiply straight across, but don't forget. So when we square 4, we get 16 seconds squared. Okay, so now we're going to multiply 1/2 times 9.8 times 16 seconds squared. And you're going to see that, you can do that on your calculator, but look how the units are going to cancel. The seconds squareds are going to cancel out. And you are going to be left with 156.8 meters. Final answer. All right, another slide. So this next one, are your heads exploding? Okay, cool. So acceleration due to gravity on Earth is 9.8. So Earth acceleration is 9.8 meters per second squared. But the acceleration on Mars is 1/3 of that. So if I'm going to try to figure out what is 1/3 of the gravity, that's going to be, let's see, 1.3 meters per second squared. So on the test, it's going to ask you, how high will the ball travel upward? So if you have a ball on Earth and you throw it, let's say, 5 meters in the air, and you threw that same ball on Mars, they're saying how far will that travel? So it's very similar to one on the test. Now, basically what you're going to need to do is you'll figure out how far your ball goes first, and then you'll figure out how far the ball goes on Mars or the moon or whatever it is. Now let me tell you, remember that acceleration is in a downward direction. Acceleration, so that basically means that you can throw the ball up, but it's going to only go so far because it's being pulled downward at 9.8 meters per second. So think about it. That's a pretty, like if we drew it like this, like a big arrow, then the acceleration on Mars is smaller. It's still pulling it downward, but not quite as strongly. So if it travels 5 meters up on Earth, do you think it's going to travel farther on Mars or not as far? In fact, if it traveled 5 meters up on Earth, it would basically travel pretty much 3 times higher, to the tune of about 15 meters up, because gravity is 1/3 of the amount on Earth. So see how we've pretty much just taken this bottom number and we multiplied it and we got this. Just keep that in mind. It doesn't have as much of a pull. Okay, so I think you guys are pretty well prepared. Just definitely have to know about acceleration, but you're allowed to use your notes. I've prepared you well, so do your best. Remember to show all your work, and I'll see you guys tomorrow. Sorry I had to miss today. I promise you I would rather be teaching physics than be covered in toddler barf. Okay, see you guys tomorrow. Bye.